I'm going to talk about what maybe is one of the most one of the themes that is most associated with technology, or at least was when one of the biggest IT companies or technology companies changed their name to Meta. And I think a lot of people say, well, what does NVIDIA have to do with Metaverse? I know you do PC gaming, and I know you do some maybe AI work or high performance computing. You're partners with Dell, with some of the other companies up there. But what exactly is NVIDIA doing in the Metaverse? And so I'll go through and talk about that today, and hopefully make it relevant to all of you, talking a little bit about how from a consumer or individual user, it may be interesting to you in your job or in your personal life, as well as how it has real applications in industrial uses. Or industrial uses, so-called digital twins is one of the big areas that we're working on.
Hold on one second, Mark. We, for our online audience, the Wi-Fi connection to the various laptops running the presentation dropped briefly. We're replacing it with a wired connection on both laptops, so it should be consistent from now on. Apologies for the drop for the online folks. Take it away.
This is why I have wired laptop at home after, the first 6 months of changing every Wi-Fi part in my house and still being able to drop out of calls in the Metaverse during COVID. But a wired usually works better. So let's go ahead and get started. And what I'll do is this, to give you an extra few minutes with whiskey, and for the all important questions, I'll make sure to get done at 7:25 or earlier. So one of the ways that our CEO, Jensen Huang, started talking about the Metaverse is he called it, well, it's really just a 3D version of the internet, or it is the 3D evolution of the internet. And that sounds a little bit funny at first, but as I actually go through and talk about the technologies that are built into Omniverse, and what Omniverse is a platform for building digital twins, a platform for building virtual worlds. It makes a lot of sense. The internet, some of you grew up with the internet, some of you looking out there, remember when the internet first started. But the internet primarily designed for 2D data. And of course you say, well, that's odd. I watch videos on the internet. I can download some Adobe 3D file on the internet. But fundamentally, the internet started as a 2D type of experience, putting documents online. And of course, HTML, the language of the internet, was very well suited for 2D data, not so much for 3D data and the interactions around it. So we'll talk about how improvements in that were built into Omniverse, yet some of the very, very basic principles of the internet. And maybe I'll even ask a question on it, is you say, well, what were two of the basic features of the web server? Were the concepts of caching and linking. So at the end of the presentation, I'll go through and say, well, how does that apply to the Metaverse, and what tool within Omniverse resembles the web server? If you think about it, NVIDIA has two basic software platforms that we run. One is all about the NVIDIA AI platform. If I was talking about something else today, and in fact, tomorrow I'm at the Dell HPC community meeting talking there, and I'll be talking about our NVIDIA AI platform and of course, ChatGPT. Everyone has to talk about ChatGPT if they're thinking anything about AI. And, ChatGPT is a very interesting, would be great to have a discussion here in sort of the Austin Forum spirit of the impact of technology in society. There's now real estate agents that I read are using ChatGPT. You just type in a few words, say, write a listing for a 2-bedroom, view apartment in Austin, and goes through and we'll go through and write 90% of the listing. It's that last 5% or so that you have to be careful from. But think of the internet 20 years ago, right? Before you had a smartphone, before so much of the internet. And think of what you do with the internet today. And think about ChatGPT and sort of the general class of what's called generative AI, generating images, generating text, generating a text response. We're in the very early days, right? November 28th, November 30th, it was introduced by OpenAI. They had 1 million users their first week or two. Their first month, they had 30 million users. It's now 2 months old. Jay already has a podcast on it. It's only 2 months old, and they have 100 million users now. Some exceptional growth, but it still is text-based. It still is that sort of 95%. And if anyone was a software developer, well, getting a software program 90% correct or 95% correct is the easy part. It's that last 5% of the debugging that takes most of the time. But think ahead to 5 years from now. How is ChatGPT going to apply? But it is very relevant to NVIDIA Omniverse, because as you build digital twins, it's really about two things. One is about putting all that data in a digital format, digitization. And you say, well, that's nothing new. People have been working on digitization for years, but putting it in a form that's as easy to use as browsing for your favorite shopping site in a web browser. Think about this building. It's a beautiful building. I took a picture of it, sent it to my kids as I was walking down from downtown of the outside. Everything in this building, it's a fairly new building, was probably created digitally, right? The blueprint of the building was done using one tool. The chairs in here, maybe probably manufactured overseas somewhere. There was a blueprint, a design for that. The carpet, right? Someone designed the design of the carpet, transported that, sent that to some digital machine at the carpet factory that built it. All of your devices, right, that are in here, of course, all existed digitally before they were manufactured. But think about today, if the library wanted to go through and bring all that data together, very, very hard, right? They probably have an Adobe or a PowerPoint or Adobe or some brochure on the library that shows the beautiful event space. But now if someone says, well, how many chairs can I fit in the event space? They say, well, 175. Well, what if I wanted chairs and desks? How many would you fit, in different designs? There's no way to go from that blueprint. There's probably long lost or some archive and bring it forward, so that if then the designer of the brochure that's sitting using Adobe to go through and do that. So if anything, the metaverse needs tools to bring together all of the 3D data. And you say, well, I can export out of any 3D design tool and probably import it into PowerPoint or import it into some other tool. But if you've ever done that, you know that, well, it's very cumbersome. It's like sharing data on the internet 20 years ago, right? You have to export out of the tool, import into the other tool, go through and figure out how to import it. I put up my PowerPoint slides on Google Docs, and Jay said, well, I downloaded it and I had to edit some of the text because the text came through the wrong size somewhere in the conversion between the tools there. So our primarily 2D tools, right, or the 3D tools were designed in silos and don't work well together, right? And today, that's one of the things I'll talk about, how NVIDIA Omniverse does that. The second part of that and how AI applies is in digital twins. A lot of people say, well, I've got some rendering tool or I've got some design tool and it can bring in all my data. It can create here's my digital twin of my jet engine or my jet airplane. I've got all the design and it exists digitally. But remember, a digital twin isn't just about representing that item in a digital space and it's a digital tool. It's about being able to associate behaviors of it. How does the jet engine work? How does the plane fly? In order to do that, your tool needs to be able to do simulation, right? Hence the digital twin. Whatever it is in the real world, you want to go through and map to a digital world and be able to simulate that. Video games, people say, oh, a digital twin is a lot like a video game. Video games don't need to follow the laws of physics. A digital twin of a jet aircraft engine needs to follow the laws of physics. Let's see, maybe when we, I've got the wrong, I was doing the pointer. Let's see if I can. So, Metaverse. What is the Metaverse? Well, our customers today of NVIDIA are building and using real Metaverse applications. So again, you know, in this talk is not about the Metaverse for social networking, though some of the same concepts apply. Many different types of Metaverse applications are there. One of the most common and one of the early tools that NVIDIA developed worked hand in hand with some of our AI software for self-driving cars. Now, I actually didn't see any today when I was walking over here, but I'm sure when you walk around Austin on a normal day, you probably see some AV company driving their self-driving cars around Austin. You see it as the LiDAR, the different sensors on it, you know, some cameras on a big camera bar, maybe. It's driving around and it's collecting data. And then potentially besides collecting data, they have their AI program that they're testing, right? It's recognizing where the lanes are, seeing when there's a pedestrian and stopping and driving that car in a test pattern. And then it makes some mistakes. It doesn't catch a stop sign, doesn't see a pedestrian. The safety driver takes over. They send all that data back to their AI factory, to their supercomputer, retrain the data, relabel the data if needed, and then go on in building the software. Well, there's been estimates made that to build a full self-driving car stack that can drive on any road in the world, you'd have to drive around 11 billion miles. So even Tesla, that has over 1 million cars out there now with their autopilot hardware on it, capable of collecting data, even Tesla could not drive 11 billion miles in any reasonable amount of time. And then think about it, as soon as you make one change to the software, you need to redrive that 11 billion miles. And so that's why Tesla's autopilot is always, there's a new version coming 2 weeks from now that is almost ready to go, right? And it's not that Tesla isn't doing a good job developing the software. It's a very, very hard process, very computationally intensive. Tesla talked about their supercomputer that they use to build their self-driving car software. They said over 7,500 NVIDIA GPUs in that system. What they didn't talk about, and I don't know if Tesla does this, but what NVIDIA does for our self-driving car stack, it's going to show up in Mercedes at the end of this calendar year, in the Volvo, the new Volvo EX90, and then the Polestar 3, and Jaguar Land Rover next year, a number of other cars. What we do is, of course, we drive test cars around and collect data. We have some in Silicon Valley. We have some in Germany. We were the first company to be authorized in Sweden to be able to drive on public roads in Sweden and test our self-driving car software. But for every mile we drive in the street, we're driving millions of miles literally in the metaverse. So in our data center, we have think about it, we have a stack of computers with GPUs that is simulating the driving environment. This is no different than if you're playing some video game. This is not that different than if you're playing some video game where you're driving a car around a racetrack, right? You're the driver, you're driving the game, and the GPU in your PC is generating all of the roads that you're driving on. So we have one set of computers that generate the roads, but we don't have a bunch of 18-year-olds or 16-year-olds in our data center driving the cars, right? We actually put the self-driving car computer from the car. We put it in the data center without the car, right? But it's the same exact computer, and run hardware in the loop simulation. One GPU simulating the driving environment. And then instead of you playing the video game, the real GPU that goes inside the car running the real software is driving it. So that's a great metaverse application. Amazon, we can talk publicly about it. Amazon uses an Omniverse application in their warehouses. Again, their warehouses are not 100% automated, but in their warehouses, of course, they have a lot of pick and place robots, as well as humans that go around and pick things out of their warehouse. Well, it rained today. I don't know where the nearest Amazon distribution center is, but I bet you tomorrow they may be selling more umbrellas than they did a week ago, depending what the weather is. Maybe tomorrow, I notice it's not supposed to rain, so it wouldn't, but yesterday they would have been selling more umbrellas, right? And so what Amazon does every night, they go through using an Omniverse application, they go through and they look at what they predict are their most common selling items, and then they go through and they run a full simulation of the warehouse, all the robots as well as the people that walk around in the warehouse, and they move the bins, these up on the top right, they move the bins of umbrellas closer to the front, to the packing stations. So they're simulating their warehouse, they're simulating all of the activity in the warehouse. In the middle where you see those shiny pipes, that's a Siemens steam power plant. No matter what the energy source is, a lot of the world's power, whether it's coal or nuclear or natural gas, is generated still by steam power plants. The problem is with the piping in those plants needs to be historically changed every 10 years. Because when you have steam going through pipes, you get residue, you get contamination in the pipes. And of course, it's very, very expensive, right? You have to shut down the power plant for weeks or months at a time every 10 years to go through and replace all of the steam plants, all of the steam lines. So they're now in Omniverse simulating the physics of the steam plant and simulating the pipes. And now they can predict when there's going to be a failure in the pipe, getting 20 to 40% longer life on average, and being able to go through and do repairs before actual damage occurs. And finally, one of the metaverse applications I'm most interested in is a project that NVIDIA calls Earth 2. Earth 2 was announced after we built our Cambridge 1 supercomputer in Cambridge in the UK. And so people thought, well, okay, Cambridge 1, Earth 2, what are you're gonna call the one in Silicon Valley, Santa Clara 3. So they were just thinking, oh, Earth 2 is a supercomputer that's going to be used to simulate climate on a global scale. Well, Earth 2 isn't a particular supercomputer that we're building. Earth 2 is actually a software suite built inside Omniverse that we're using to simulate climate. And you say, well, aren't there, doesn't NOAA, aren't around the world, aren't there government agencies that have been simulating the weather? What does weather.com do? Aren't there satellites out there and airplanes, going after storms? Yes to all of the above. But going back to the AI part, simulating climate is a physics problem, right? You have to simulate the laws of physics. How does water vapor form in clouds? Unless you can tell how water vapor forms in clouds, unless you can simulate it, then you can't actually do a climate simulation. Well, it turns out that if you can train a deep neural network, an AI program, to recognize, a pedestrian and a bicycle and a motorcycle for a self-driving car, and if you can train Chat GPT to go through and take Jay's questions and answer them 95% correctly, well, then why can't you train an AI program to understand the laws of physics? And so that's one of the other Omniverse tools that we've built is for certain laws of physics. Again, we started with water vapor for clouds. We have many, many more laws of physics to go, and we're working with a number of different partners, including most of the world's weather agencies. Let's see if there we go. It's working now. So here are some of the different, I talked about a few of these already. Drive Sim is a tool built on top of Omniverse to simulate a self-driving car. Isaac Sim does the same thing for robotics. Robotics, you can think of it as two ways. That little robot going around the Amazon warehouse, first you say, well, that's just like a small car. But it's actually much harder, and it's a different set of technology to simulate. And why is that? And why is a self-driving car easier than a self-driving robot? Well, a self-driving car is designed to not interact with other things, right? You don't want it to hit people. You don't want it to touch people. You don't want it to pick up things with its bumper. A robot, most of the robots, you want to interact one way or another with a human, with another robot, with something sitting on a shelf. Omniverse ACE is our avatar cloud engine. Now, again, this is one of the things with ChatGPT. You know, you say, well, is this really real? How does it work? Because it's just text. And so think about it. There's a lot of things that when you think about what AI would need to be behind that, the AI is very much within the state of the art. Think of going through and ordering a hamburger at your favorite fast food restaurant. I'm from California, so I would say In-N-Out Burger, but I don't know, that maybe be a question. What's your favorite hamburger chain in Austin? I'm sure there's some that are favored even more so than In-N-Out Burger. But one of the applications, one of the early applications of ACE was building an automated kiosk, right, for quick serve restaurant types of applications. So think about it. You've probably, if you've walked into a fast food restaurant today, they have some little kiosk there, and you can go through using just text and sort of pick. I say, I want a cheeseburger and some French fries, and they'll say, do you want an apple pie with that, or do you want a Coke or 7-Up with that? And may even have some of your preferences behind that. But think about how much more real that would be if that was human-like, face sitting there and talking to you with that. And then think of all of the different, you need to recognize images, you need to recognize voice, you have to generate images and voice. All of those things are things that AI can do today, but putting them all together to work in real time, or at least in a conversational speed, AI is very, very useful. Now, there's the societal aspects of that are interesting. You might say, in NVIDIA, or people that use this NVIDIA technology are I walked by the Deloitte building on the way here, and Deloitte's one of our partners that is one of our early access partners that's using Omniverse ACE, and specifically with some fast food restaurants for these types of applications. You say, well, Deloitte is just going to, take away jobs because, fast food restaurants workers will be out of jobs when this technology is optimized by Deloitte. Notice that I'm blaming Deloitte. I'm not blaming NVIDIA that's developing the software for it, but hopefully there's no Deloitte people here. They're online. They're a great partner. So, you got some free PR. But as I was walking here, I walked past about 10 different fast food restaurants. Every single one of them had a sign out front saying help wanted. I don't know what the minimum wage here is in California. And I forgot that the whiskey tasting is competing with some big national TV broadcasts. I don't know if they'll watch that in Texas or not, but I think it'll be recorded, I'm sure. And so And so, but think about it. Every fast food restaurant is advertising for help. There's not enough people in Austin that want to work at fast food restaurants. And think of the McDonald's or the chain, right? They need people for the morning rush. And boy, the rush hour here, you know, every time I come here, I don't get here that often, but there's a new condo building going up, a new office building. The only thing they're not building new of in Austin is new public transit of any type. But that would be a good omniverse simulation to simulate traffic in Austin and do a digital twin of that and say, okay, if I'm going to put an apartment building or condo building here where needed, but back to fast food, right? And so if many people want an 8-hour-a-day job, right? And can't afford or don't want to work for just a couple of hours. But when does McDonald's need people, right? From 7 to 8 in the morning, from 12 to 1 for lunchtime, from 5 to 6. And, you know, no one wants to work 3 different split shifts like that. And again, you're still going to have people in McDonald's because these sorts of technologies are going to be, for a while at least, 95% accurate, just like ChatGPT is. Right? It's not going to be magically better. And so you still need the human there working at McDonald's, but going through it and offloading at peak times, I think is very good. But again, these are sorts of you know, of technology and society discussions that should be had in group settings that probably the government has a role in. And, you know, you can debate whether it's local, state, or national government, but, you know, you probably don't want technology companies setting policy. I love NVIDIA's engineers, and I know many of them, but they're not policy experts. I wouldn't want them setting policy. So something to think about for technology and society. Why all of a sudden Omniverse? Why the metaverse, right? What are the technologies that came together? It wasn't just one person changing the name of their company. The one person changing the name of their company to Meta was really between the convergence of these technologies. So the first is ray tracing. Second is the compute capabilities in the data center. Third is USD. It doesn't stand for US dollar. That's sometimes I remember it. And finally, the AI revolution. So let's walk through these step by step and talk about why they're important for building digital twins for a real metaverse environment. If you play a computer game, up into even to a few years ago, and probably so even today, computer games every year, when we announce a new consumer GeForce GPU, they look more and more realistic, but they still don't look, you can still tell it's a computer game. Even if it's at 4K or 8K, it still looks a little bit, something looks a little bit off, right? If you look at a snapshot of it, you go, oh, that's a beautiful picture, right, of a forest. But then it's in the game, right? No, that's not a forest. It's a forest in a computer game, right? Why is that? Well, computer games take shortcuts and they don't actually follow the laws of physics, specifically with ray tracing. So again, we're getting better and better at ray tracing, but again, ray tracing is the technology that follows each ray of light, whether it's coming from the light bulb, whether it's bouncing off the carpet, off the screen, and traces that light bouncing. And then on top of that, applies physics to it, to the devices in it. And that's why a computer game still looks a little bit unreal, because a computer game typically isn't fully ray traced. They take shortcuts. They say, okay, let's pre-calculate the lighting in this scene, and as long as the player stays in this area under the light, it'll look close enough. The ray tracing technology that was first developed by NVIDIA about 4 years ago now was the first time you could really get ray tracing within a single GPU that you could put under your desk or in a computer. So really bringing that next level of photorealism. At the time, 4 years ago, 4 to 5 years seems to be a common time frame for technology to be going from brand new to commonplace. all of our competitors that make GPUs all said, ray tracing, it's a fad. NVIDIA can't really do it. It's just something in their marketing. Today, every GPU vendor talks about ray tracing, right? Because, again, our technology is open, is easily copied. Once we figured it out, others were able to as well. So ray tracing, the first technology to make something photorealistic. Why is that important? Not so that you have a great social networking experience. Think about it. A self-driving car, it has to be photorealistic when it's trained on AI. If you trained a self-driving car on just poor video game quality graphics, it would make many more mistakes. So again, you had to get to that ray tracing level of realism to be able to train a self-driving car. Second is data center compute, doing that physically accurate simulation, whether you're simulating a robot driving around in the Amazon factory or a self-driving car. ChatGPT, I read an article today, it estimated that Microsoft had spent $4 billion over the last 2 months on ChatGPT. Not to train the network. Everyone always says, oh, I know, I get it. To train GPT-3 takes 4,000 GPUs 1 week to train, and 4,000 GPUs costs a lot to rent. Even you go to Amazon, rent 4,000 GPUs for a week. It takes a long time. It's not the training, it's just given all the users, and again, this was a financial analyst estimated the cost of the GPUs and the cost of everything else. And so of that 4 billion, only half was for the GPUs. That's the good news. A lot went to the data center, to power, to the CPU vendor. There were some great CPU vendors that were sponsors today, and so a lot of good business for them. Third, USD. USD stands for Universal Scene Descriptor. USD, going back to, USD was first developed by Pixar, the 3D animation company, is a way to exchange data between different Pixar tools. And again, they needed something that represented not just the attributes of the 3D data, but a tool that was layered. So you could put material definitions on it. So you could put different behaviors of the material, properties of the material, any sort of arbitrary layer to go through. They came to NVIDIA. They asked for our help implementing it. We liked it so much, we picked it as the standard for Omniverse. But we told them, look, we're going to pick this. We believe Omniverse and the Metaverse is going to be the 3D internet. The 3D internet can never be owned by one company. Think about it, right? The internet was created not because Microsoft owned HTML, right? The internet was created exactly because Microsoft did not own HTML. It was an open standard. And so Pixar worked with us, open sourced USD, and USD now is the equivalent of HTML for 3D data and for simulation data. We have today over 250 companies make what's called a USD connector. A USD connector is just a way to, think about it, when a web server wants to read your file, you put it in HTML. Even if your PowerPoint and you don't speak HTML natively, you can export into HTML. That's the PowerPoint HTML connector. So about 250 different 3D tools, IoT tools, factory tools, and other types of software interfaces now go through and speak USD and have importers and or exporters. So USD is now becoming, for the 3D internet, for the metaverse, is becoming this language like HTML that promises to make 3D data as interchangeable between different tools as 2D data is today on the internet. Finally, the AI revolution. Again, many of the different things that you need to do to create digital twins require AI. Many of them fall under generative AI, going through and creating data. often called synthetic data generation. So a great example, if I am a Walmart, Walmart has about 300,000 different SKUs, different parts. And you say, wow, I've walked into a Walmart store. I didn't realize they had 3,000 different things there. A typical Walmart store only carries about 50,000. But again, across the US, across everywhere, they have over 300,000. And even more importantly, 30,000 of them change every month. So now think about Walmart 5 years ago when they could write an AI program that recognized, a box of Campbell's or a can of Campbell's soup or a box of Kellogg's, of your favorite Kellogg's cereal. And they said, okay, I want to do a self-checkout counter, right? That uses AI and image recognition. So I'm just going to go take a bunch of pictures of all my SKUs and then train an AI program on it. Well, if you have 300,000 different parts and 30,000 of them change every month, you could never keep up training on real live data. They would need tens of thousands of people just creating taking pictures of all the SKUs and doing it. But think about it. Every box of cereal from Kellogg's, every can of soup, every change on the label, it's not hand drawn. It's drawn using some digital tool. The can is manufactured in a factory. It exists. There's a digital version of that can that went into the machine making the can. And so now with synthetic data generation is a tool that actually evolved from some of our PC graphics in renderers. And this is how. When you play a video game and you see a forest, the forest was not drawn by the computer game maker by drawing every single tree in the forest, right? And you think about it, you look at a forest, there's small trees, there's big trees, some are pointed one way, some are turned a little bit the other way. What the video game maker did is gave the renderer an image of the tree and said, randomize it. Make it shorter, higher, turn it 1 degree, turn it another degree, different shades of green. And the renderer went through and created that forest scene in the video game from one single image of a tree. Synthetic data generation is much the same way and borrows on that technology and says, take an image of a can of soup and now generate 50,000 different images of that can of soup under different lighting conditions from different distances with a box of cereal halfway through. And now when you're rushing through the store and you have a box of cereal and a box of Campbell's soup and you quickly pass them through the scanner and there's a camera overhead, it can help make sure that is accurately tallied in total. So synthetic data generation is used throughout. Synthetic data generation is used as a key part of drive sim. Again, think about it, if we're going to drive 11 billion miles, everything in the world, we don't actually have someone go through and hand draw every road and every feature on every road, right? That's actually done through drive sim and drive replicator within Omniverse. So again, Omniverse is not a single tool like PowerPoint or like Adobe that goes through and creates a digital twin, creates a metaverse experience. It's a set of different building blocks and building tools. Jay was right. A lot of these slides, the text was very small in them. So again, platforms and building blocks for the Omniverse. I know sometimes in Austin, there's some software developers of like the old-fashioned type, not AI software. AI software isn't written by writing code in a computer. AI software is written through data, through in the likes. But these are some of the different components of Omniverse. It's a very comprehensive suite of tools. It can run anywhere where you have a GPU. Some components of it don't require GPUs, but again, it's a full enterprise set of tools. Here now, a little bit more on the structure and how does it work. We talked about a lot of different things, from self-driving cars to Walmart, and how do you get started? What are the basic components? Well, again, as I said, there's over 250 different tools that exist that have connectors with USD. And if USD is the HTML, then Omniverse, to build a virtual world, you also need the equivalent of the web server. And so remember, many different companies can write a web server because HTML and HTTP are standards. And so we wrote our own web server for Omniverse or USD, and that's called Omniverse Nucleus. Nucleus is Nucleus is that data hub that lets you publish and subscribe, input to, output from all the different 3D tools. A simple way to think about it is Google Docs for 3D data, right, in 3D design tools. But you say, okay, well, how does that work? I'm General Motors and I want to build all of my car plants and put every data on every car in Nucleus. That must be a really big Dell server, and how many GPUs does it have in it? Well, that's sort of like saying, what is the web server at General Motors that holds all of their documentation, right? There isn't just one web server, right? There's many web servers. And how do web servers, but then somehow when an engineer at GM goes and wants to download a document, it just shows up. Even if that document is stored halfway around the world, they don't have to have it stored there. So Nucleus is based on the same concept, two very important concepts of a web server, linking and caching. So when you load data into a Nucleus server, it's basically just caching a copy of that data and linking to the source. This goes back and really helps a lot of security, privacy types of issues. Think about if you're building a digital twin of a factory, you would like the person building the car and the person, simulating the robot, all to be able to interact together and make changes. You're designing your house and you're working with the architect. You'd like to have the architect be able to change something, and then you'd like to be able to change something using PowerPoint, maybe using Photoshop, a different tool, share it with the architect. But then when you press go and say, okay, now build the house, build the car, you want that master copy. You don't want the architect going in and saying, oh, I'm going to make one more change, right? So again, the source of the data, the truth of the data stays in the tool and whatever the data source is. And Nucleus is just acting like that caching, linking web server for all of the data. On top of Nucleus, you have a number of different microservices that you serve, and a set of basic tools that NVIDIA has built. Omniverse View. Omniverse View is a tool that lets you view any of these 3D data formats, right? I don't know how much Adobe PowerPoint costs now, right? But it's an annual subscription. You may not want to buy it for all of your kids, right? If you're sharing the design of your house. So Omniverse View is a tool that lets you view any of the data from any of these tools. Same with Omniverse Create. Omniverse Create is a tool that lets you create your 3D data. Is it a replacement for CATIA, for some other tool? Of course not. It's just a way to bring in all the data from all the different tools and then be able to manipulate it in a form. So some of the different components of Omniverse. Many different ways to connect. Here's some of the different tools out there that are connected to it today. And again, let's talk about some of the other tools. Omniverse is very, very interesting in that it's actually all written in Omniverse, right? And so a Kit is basically a scripting language within Omniverse, and the different Omniverse applications, the create application, the view application, the simulation applications are all written as Kit applications. Omniverse has its own sort of development environment for developing Kit applications in them. And then all of these work across USD. There's a number of different reference applications that we've built. I won't go through all of these, but one of the ones we did was AI-enabled face animation. It's a tool called Omniverse Audio to Face. Now, again, you may say, well, all this is going to do is create, deep fake videos. And yes, it can help to do that. But think about it. If you want to build that kiosk, right, and you wanted to make it lifelike, it's not enough just to have it look like lifelike skin, which of course a video game can do. But it turns out, right, that your face has about several hundred muscles in your face. I always think when I think of anatomy, my daughter is a doctor. So I think, oh, if I ask her, she could say how many muscles I have in my face. But audio to face was trained by looking at many different samples of people talking while they looked at your face and your face muscles. So it doesn't actually understand the structure of the muscles in your face, but it understands based on when I say certain words and even on certain emotions, how the muscles look when I'm doing that. So now I can go through, create an AI application like a talking kiosk at McDonald's and go through and have it respond in very lifelike, realistic types of ways. So again, a number of things that we've done in the platform to give Deloitte and others the starting point. I think I said those. I'm not sure if this even had sound in it, but here's an example. So you can do all sorts of faces, right? Human faces, rhinoceros faces, others. And again, this does not need a supercomputer. This was trained on a supercomputer, but it actually just needs a standard, any sort of desktop GPU to run on. One of the things before you get to digital twins is, of course, that Omniverse is useful for is the design process. We've been working with BMW and now Mercedes for over 2 years to build a digital twin of their car factories. And BMW is probably the farthest along, and there's still a lot of work to do. But BMW is already making very good use of Omniverse. And again, think about how many times different 3D data needs to be exchanged in building a car. Someone used a 3D tool like CATIA to design the car, right? You've all seen 3D CAD models somewhere. Well, you know that when they do the brochure in the magazine or the nice image for the website, for the car configurator on the website, they're not doing that in CATIA. It's some marketing person creating the website. I don't want to say that. I know that Jay said that people were doing marketing. I could never use Photoshop, right? The way that an illustrator in our marketing department could. But again, when they have to take the output of CATIA, the tool they're not used to, import it into Photoshop, do the touch up, and then if they actually have a good idea, well, let's make the rearview mirror red, or let's put black stripes down the bumper, or whatever. Then they have to call up the engineer that's sitting with CATIA. And this is how design reviews are still done at auto companies. Often they go through and they have 30 or 40 different tools used in the car design. Each designer decides what they want to show in the design. They take a screenshot of their tool And then they import that screenshot into a PowerPoint. And then when they're ready to show the car to the CEO or the VP, he or she sees a PowerPoint because it's showing 30 different design tools, all through screenshots in PowerPoint. And now think of the power if you could sit there, have all those 30 different parts of the car, whether it was the marketing department creating some paper brochure on it, all the way back to the core engineer doing the crash analysis or some other, go through and all interact in real time on the same data and see changes in both ways, back and forth across the tool. So Google Docs for design tools. It sounds, think about the first time you thought about Google Docs, it sounded pretty amazing, and you would know Omniverse Code. This is our IDE for building the development environment. Omniverse View, we talked about that briefly. Omniverse Create, again, layout of the different tools. We have, of course, a Create XR. I said, I was going to say at the start, okay, I'm not going to talk about XR or VR or AR at all, but again, one XR snuck in there. Omniverse Replicator, we talked about this. This is a tool that lets you create synthetic data using AI-based technologies. Physics simulation. Again, for a factory to be real, for any sort of digital twin to be real, it needs to follow the laws of physics. We have some basic libraries for things like rigid and soft body dynamics. Again, think about a robot picking up this little pointer that is fairly hard plastic is very, very different than a robot trying to fold a towel, right? Because a towel isn't hard plastic, right? You have to have different tactile feel. So simulating the physics of it is very, very different. A number of different third-party tools, again, have written USD connectors that let them import their physics models into it. And the one that we built for both Earth 2 for the climate simulation, as well as many uses in just the IT industry. So if you are lucky enough to get one of our new DGX H100 8-way GPU systems that just started shipping, it has, besides the GPUs are all connected with a high-speed interface called NVLink. The NVLink is a point-to-point interface. And of course, with 8 GPUs, that'd be miles and miles of copper wiring on the PCB. So we do the same thing that you do when you want to connect 8 wired laptops together, is you use a switch, right? So we have a little switch chip inside the DGX H100 called NV Switch, and the heat sink for that was actually designed 100% with AI using Modulus. We had a team use Modulus to do the design, and we had a team use standard CFD tools to do the design of the heat sink. The AI created heat sink ended up being about 15% more efficient, and we're shipping it now. Omniverse Cloud, Omniverse is the sort of tool that it has to run in the cloud, right? How would you create the internet if it just ran on-prem, right? In your office, in your factory. And so NVIDIA today is the software, of course, runs in the cloud, and we're in early access with a service called Omniverse Cloud. NVIDIA, all of our software as a user, you can take that and run it in any cloud. And sometimes we let the cloud service providers, use our software in their tools. So for instance, our Triton inference server is used in Bing search, it's used in Amazon search, but Omniverse today as a service is only licensed as a cloud service through NVIDIA's cloud services. Media and entertainment, the use cases should be there. This is an interesting example of one of the early use cases of Omniverse in media and entertainment. In the past, if you wanted to animate a bear, you had something that the movie director had something that looked like that bear on the left, a hard surface, and they would go through and sort of storyboard that online, and then overnight, they would go through and render it and render the fur, which is, of course, much harder to do. Now with Omniverse and some of the Omniverse tools, you can go through and do that in real time. So they basically get that movie quality of fur on the bear and can look at all the lighting, the scenes, and the likes. Turns out fur is something that, because think about how the light hits fur and transfers through fur, is very, very hard to simulate without ray tracing. So anyhow, I'm going to stop there. A few minutes ahead of time, and I think we're going to take some questions. Well, we have an MC here, so some questions will come from the audience and maybe some from Slack. Or are they only from Slack?
All questions come from Slack. We
Okay.
want to put everybody on the same basis, in person and online. And a great welcome to our online audience. We had over 100 people online, so that means we had nearly 200 people watching this event. So let's give a round of applause for Marc. And now I'm pleased to bring to the stage our newest advisory board member, Steven Strauss from Kung Fu AI. Please welcome Steven.
Thank you very much. That was great. Appreciate it. I'm Steven Strauss, and I'm one of the co-founders and I'm managing director of Kung Fu AI. That's kungfu.ai. And we are an AI professional services firm. So I have a bunch of questions here that I'm going to put to you. And the first one is from Scott Collins. Scott, are you in the room? There you are. Thank you, Scott. So Scott's question is, how will humanity most benefit from digital twins in the next 5, 10, or end 20 years? So we saw lots of applications, but what do you think is going to be most impactful for humanity?
We should have like Jay typing this into Chat GPT and see what it says. The problem is its data is only up to date to 2021. I think some of the most impactful applications will be in making better factories, making factories that are more productive, that require less labor, that require less back-breaking labor. One of the very early learnings from BMW, and one of the things they changed in their latest South Carolina factory, where they build their electric SUV. I know electric and SUV in Texas don't always go together, but BMW is building one. Is in a factory, right? The robot, rolls up a part with the parts that need to be assembled on the car that a human still has to do. And so what does the human do? The human has to go in and pick up the part and then assemble it in the car. And so one of the very early simulations, they had the factory worker was doing 3D motion capture, which you can do now just with a regular video. And they realized that they were bending over much too far to have to pick up this part. And so they made an adjustable cart that then, depending on the factory worker and how tall they are, which again is all in the system, they can adjust the cart so that they have to bend over less. So I think it's things like that that we don't even think about, small things that are going to be, huge improvements.
That sounds great. Thank you. We had multiple people ask questions about security, and one of them is from Eric van Hansbergen. Are you here? Right over there. Thank you. And the question is, how does NVIDIA propose handling security and privacy concerns, both within the Omniverse and with the data used to calibrate it? And more generally, talk to us about security.
So at NVIDIA, we really think of security as a full stack computing problem, right? And that's, but let me explain that. But first, let me address with Omniverse a little bit. I would say it's if you just think about or ask what's the security of Omniverse, that's saying, well, what's the security of a web server? What's the security of a web server that's locked up in your basement data center? What's the security of a web server that's running in the Amazon data center in AWS? Does it depend on what hypervisor you're using or what CPU you're using? So we think of security in a lot of ways. With it, the lowest level are features of security that we build into the chip. So our H100, besides being very highly sought after by ChatGPT and similar types of startups, it includes a feature called confidential computing. And so confidential computing lets that GPU, when it's running in Azure's data center, and even if the GPU is being shared through multi-instance GPU, make sure that all the data is always encoded, not just at rest, but encoded in motion. So it's going over an internal bus on the server or anything. It's encrypted in there, and it's encrypted when it's sitting in memory to give a very, very secure cloud environment. At the next level up, the network. All of the cloud service providers. One of the things. If you use the cloud, you don't think that much about infrastructure, right? You're not thinking, oh, is it a 4RU server or 2RU server? You just think about what the specs are, right? What CPU is in it, what GPU is in it. In networking, you think about is bandwidth. How many gigabits of bandwidth does it have? But every single cloud service provider uses some sort of smart NIC. Today, sort of the term DPU has been coined for that. And they do that for security. They're offloading the security, offloading sometimes the hypervisor into the smart NIC. And so NVIDIA was one of the first to productize smart NICs for the enterprise in our Bluefield line of DPUs. And one of the things that we built is a software layer on top of that called Morpheus. That is a AI software layer that lets you do digital fingerprinting. So if you have a network of 1,000 users that are working together in Omniverse, and then all of us in Morpheus can go in, run on every DPU on every server in your network, report back data, and Morpheus goes through and uses AI rules to look for anomalous behavior that's never seen before, something that AI is very, very good for. And so typically that's called digital fingerprinting. So we're working at security up and down the stack, but at the end, I think a lot of the questions about your security will also go back to policy, right? What's the number one source of data leaks on Amazon? Not a bug in Amazon software or hardware. It's someone leaves an open S3, a public S3 bucket, right? And your social security number is in it.
I appreciate it. That was great. This is a two-part question. The first part's from me. Second part is from Timon A. Timon A here? Yeah, there you are. Thank you, Timon. So you might have mentioned at the beginning, but could you repeat what your role is at NVIDIA? And the question from Timon is about the technical future of GPUs. So what's the outlook for future GPU processing capability? Are we close to a theoretical limit? And then he writes, which I don't really understand this part, that may limit the usefulness of tools such as Earth-2 or DriveSim.
Two-part questions are always hard, but the first part was an easy one. So my official title is I'm Vice President of Solutions Architecture and Engineering, and that doesn't tell you anything. But basically, my team's job, NVIDIA is a relatively small company compared to some tech companies. We have about 25,000 employees. About 21,000 of them are product development engineers. And of the 4,000 left, 600 of them are on my team. They're all engineers. And what my team's job is to help our customers, whether they're Amazon or GM or Bank of America or University of Texas Advanced Computing Center, use our technologies. Right. And again, going back to the question of the GPU, we actually Jensen Huang likes to say that Moore's law is dead, right? And by Moore's law is dead, he doesn't mean that, Moore's law has a lot of different definitions, right? The common take of it was that the performance of a processor at the same price would double every 12 to 18 months. And another version of that is, well, how many transistors are on can you build on a chip? Well, actually, the number of transistors that you can build on a chip continue to go up. Right, we went from, we're now TSMC is building 7 and 5 nanometer, experimenting with 3 nanometer, 2 nanometer down. So at a certain point, right, you can't make transistors any smaller than an atom, right? But beyond that, today, if you look at the cost of a TSMC 3 nanometer transistor, it's actually more expensive than a 5 nanometer transistor, right? So in effect, just doing things with those transistors, just putting more floating point engines on it that just do multiplication the same old way, do not actually lower the cost of computing anymore. So that means that we have to make GPUs more powerful. Yes, we will build, we'll take advantage of all the new transistor technologies available, but that we have to look at it as a full stack problem of acceleration, right? And so again, that's why we spent $7 billion acquiring Mellanox coming up on 3 years ago, because right, to build a supercomputer, one of the most important things is networking. Of those 21,000 engineers we have, people say, oh, NVIDIA is a great chip company. Only about 4,000 of them build our chips. And that's a lot of chips now, right? The GPU chip, we have our Grace CPU chip we're building, we have all of our networking chips that we build. And so about 15,000 of our engineers work on software. And so again, a great point in do things get faster is today, the H100 GPU running MLPerf, the sort of industry standard MLPerf benchmark, is 6.5 times faster than the Ampere A100 when it was released 2 years ago. So 6.5 times faster in 2 years. But that's a little bit misleading. The A100 itself is 2.5 times faster than when it was released 2 years ago. If you bought a Dell server 2 years ago with an A100 chip in it, ran MLPerf, and that same exact server, you never touched it, you never did anything to it. All you did is load the latest NVIDIA software on it. It today runs 2.5% faster, 2.5 times faster, right? So we're continuing to push forward because, it's again, we love tough problems.
All right, thank you. Is Christoph Landa here? There you are, Christoph. So Christoph asks, given the leap in capabilities in the NVIDIA Omniverse, what would you recommend as far as education to get into the development of these tools to take it to the next level? It seems like there's a lot of learning that has to happen. What's the best way to get into this?
That's all that learning is good job security for my team, because again, with 21,000 engineers, and we're spending several $1 billion a year on R&D, and so all of that directly translating into new products. So learnings. A number of great learning resources. One is I'll put in a plug for the week of March 15th. I think, is our GPU technology conference called GTC. A lot of companies, they go to Las Vegas, or they rent out downtown San Francisco, or they have a rock band come play. And Austin already has great bands come and play at their event. So we don't have any rock bands. Our events are now fully digital, but we have in our GPU technology conference, we have a keynote by our CEO, of course. So he always likes to keep the announcements to himself. So I can't pre-announce anything he's going to announce, but I will say some of them will be in the area of Omniverse, and he'll have some amazing demos as well. But there's over 400 technical sessions, right? And these are not all just my son's is actually a machine learning engineer. It's just NVIDIA, you're just trying to brainwash people. I go, well, no, GTC, about a third of the sessions, technical sessions by NVIDIA engineers, about a third of them from our partner engineers, VMware, Dell, ARM, AMD, on and on. You saw, NVIDIA is the only AI company that works with every AI company in the world. So if, every AI company is welcome there. And then about a third by our customers, right? Lockheed Martin was talking last time. I think they'll give an update this time, how they're using Omniverse to fight forest fires. I don't know how many forest fires you have here in Texas, but I know in California that's a huge challenge. So that we have our Deep Learning Institute. There's a number of courses there, and for enterprise customers, this doesn't help you as just sort of an individual, but we have a very special cloud that we launched. It's called NVIDIA Launchpad. It's not a cloud like AWS that you come rent GPUs on. It's our proof of concept cloud. And so if you're an enterprise customer, someone that would buy our GPUs, you can go through and get a free account on NVIDIA Launchpad, and it's time limited, and we have about 50 different curated labs that you can walk through. And besides doing the labs, you can run your own proof of concept, and that's all runs on servers from one of our sponsors, Dell. NVIDIA buys the servers. We didn't get them for free from Dell. That always give us a great deal, but again, that's a free cloud to do training on.
So one of the takeaways I take from that answer is that there's definitely entrepreneurial opportunities around learning around this stuff. So, all right, is Jeff Zavala in the room? In the back. Thank you, Jeff. So Jeff asks, what methodologies can be utilized to ensure the decentralization of the metaverse to avoid the abuse of power when it's centralized? So how do we make sure this doesn't just end up in one company's hands as far as that there's no choke points, if I understand the question correctly?
Yeah. So all of, if you think about it, all of our software has to be open, right? That NVIDIA builds, or in open doesn't necessarily mean open source, but a lot of our software is open source, and that's because it's used by the largest IT companies in the world, being the cloud service providers. Think about it. And I mentioned it before, our train inference server, right, is used by Bing search, right? Satya, even though he does email Jensen now and then, is not going to call up Jensen at 12 midnight and say, hey, Bing search is down. Can you get your train engineers to look at the code, right? And so our technology, when it's used, at scale by a cloud service provider, has to be open technology, right? And I think that's one of the ways. And again, specifically with Omniverse, creating it around open standards, right? The other thing besides control is being sure to support innovation, right? If you have a closed standard, if you're one company and say, doesn't matter how great the tool is. I do actually use PowerPoint. I do actually use Photoshop now and then, and I love the tool for my personal photography. But again, if I was running, a huge business and said, well, I have to put all my data in Photoshop, and I have to wait for Photoshop to do an update before I can launch some new feature, right? That probably wouldn't be a great decision. So, the data standards have to be open source.
Okay. And Jay is telling me this is the last question. Is Trisha Tripathi here? There you are. Trisha, not only do you have the last question, but you also get the South by badge. So congratulations. And Trisha asks, how do we ensure that trust and ethics are at the core of digital and synthetic data, especially around AI-led applications?
So trust and ethics are some of the biggest challenges, I think, of AI. It's also an active research topic, right? If you look at what, there have been earlier attempts by other companies to do AI-based chat, and within a day or two they were taken down because they had zero safeguards, right, on so-called safe for work or the like. So OpenAI did do a lot of work in going through and putting safeguards around ChatGPT. It's not 100% perfect. I'm sure with 100 million users, you've seen examples out there. I'll tell you, there are startups out there in the large language model space with over $1 billion worth of funding, public. I won't mention their names, but you can go look it up, where their business plan is to do safe AI. So NVIDIA is certainly working on that research. Again, we're not a huge we don't have a huge research arm. We have about 200 people in NVIDIA research. So we're doing sort of less there than others. The other thing that I think for a lot of these things are there are policy questions, right? Again, a lot of times people say, well, does NVIDIA is you have so many video cameras in every city, what's being done with that data, right? And facial identification, right? There's all sorts of ways that facial identification can be used for good or for bad, and that's again, that isn't something you want Google or NVIDIA or Dell deciding. That's I think a role for government at some level to make policies.
Well, thank you very much. Let's give a big hand